In this video, we will introduce our next programming project, which is assignment 2, desktop calculator. And this assignment will also allow us to experiment with recursive method calls, which are methods that are calling themselves to implement the logic of the program. So in this assignment, we are going to begin with a prototype, just like we did in our first assignment. So if you click the sample code, this is desktop calculator version 3, which is the prototype for us to get started. Now I am going to create a new project for this assignment, and I will call it first of all, it's just going to be Java application, and we're going to call it assignment 2, pretty simple. And I am not going to create main class because it will be downloaded together with the rest of the prototype. So just this and finish. And of course, we are going to have only the default package, which is the root directory of our source. So let's take a look at the package name used here. So we can use this package name, and that would let us download these files without the need to change the package statement. So I'm just going to copy this, right? So this was the text of the main app of this desktop calculator, so I just copied the name, and I'll just go to source packages, new Java package, and create. I'm just going to paste this week 3 calculator version 3, and version 3 because I've changed this prototype a few times, and every time I made changes I kept unique version number, and so I ended up with this name of this prototype. So anyway, we're just going to use this package name. So now, of course, we're ready to take a look at this assignment 2, source week 3, and this is the location where we would like to store these files as we download them. So we can just copy this location, and in my browser, as I right-click, I can just say Save Link As, which brings up the dialog box that asks me where I would like to save everything. So I'm just going to specify this, just paste it in the address bar and hit Enter to navigate here. And I'm just going to get rid of this prompt and just download this as main.app.java. Click Save, and do this for all other files. Alright, so altogether 5 files, and I have downloaded these 5 files. So if we look at our prototype, you can see that everything seems to be fitting well right here. Okay, so let's go back to the assignment. So in this assignment, what we're going to do, we're going to have a program which will accept arithmetic expressions, with very simple arithmetic expressions that just use numbers, arithmetic operators, parentheses, to compute arithmetic expressions. So that's why it's called desktop calculator. So let's run this. And of course it's asking me for my main class. I'm going to use that, and this prototype simply goes to this prompt, and now it's waiting for me to type my expression. So I can type something like just a single number. It's already good as an expression, so you can see that it prints the result, and then 2 plus 5, something like this. So this prototype is not solving this expression. Instead, it's showing us internal structure that it creates for us, that we may finish this assignment and convert the structure to an actual computation of this expression. So we're going to talk about all of these specifics as we go through this handout. So this is our prototype, and actually these expressions can be as complex if you'd like. So 1 plus 5, we can use parentheses and do some sub-expressions right here, and things like this. And here I would just probably use something like multiply. Okay, so this would result in a certain way of parsing this expression, obeying the rules of operator precedence, that for instance a multiplication should have a higher precedence than addition, and all other common rules for evaluating arithmetic expressions will apply to this process of understanding what is the user input. So let's get started, and here we would like to start with the basic parser terminology. So you can see that what we just downloaded is a series of classes, set of classes, and we have the Lexer. The Lexer deals with assembly of symbols into some meaningful statement of the input language. Basically, we will recognize that the rules for arithmetic expressions limit the user of what a legal syntax of that expression is. And so the Lexer will be the class responsible for assembling all of the input into a meaningful construct that can be used directly by the rest of the program, so that the arithmetic expression can be evaluated, right? But the Lexer is directly responsible for the grammar rules of the input that we are going to allow our user to use. Syntax refers to issues regarding the grammar of a statement. So we will say, okay, this is a statement given to us by the user. It's going to be an arithmetic expression, and we will recognize certain syntax. So something is okay and something is not okay and will be rejected. The semantics refers to issues regarding the meaning of the statement. So the semantics is defined as the meaning of a symbol or a sequence of symbols. For example, of course, this is division, this is subtraction, this is a literal value, so these are the semantics that will be given to each part of input as the Lexer goes through this input and tries to understand what it's supposed to mean for our computation. So the Lexer Java class implements recursive descent parser for arithmetic expressions, and it's based on a set of grammar rules. So let's talk about the grammar in general that applies to arithmetic expressions. It's quite intuitive, I hope, and again we're going to continue with some new definitions, and you can see already after running this prototype that it already supports a lot of functionality that is needed to deal with arithmetic expressions. So the Lexer here deals with understanding of symbols in the arithmetic expression, and so these are meaningful and expressions with proper syntax that we can accept. So we should be able to properly process these expressions, those inputs by the user, and be able to print what the result is. So the syntax refers to issues regarding the grammar of the arithmetic expression. For instance, compared to these examples, an example like this should be causing an error and should be rejecting because something is missing here. There's a number, there's an operand missing, that this plus a sign representing addition, that is missing. And it should give user a meaningful error message and let them retry. So the rules to formulate valid expressions and without inputs with errors are implemented in our Lexer class. So Lexer will deal with all the input grammar, which is the set of rules, what is okay and what is not okay on the user part in terms of providing us the input.